As you can see, our fifth problem is asking us to find a second derivative. And we recall this notation for second derivative. We've got y, our function y equal inverse tangent of 2x, and we're asked to find d2y over dx2, or the second derivative of y with respect to x. Now, that means, of course, we have to first find the first derivative. So step one is determining dy dx, the first derivative. Well, we've been working, of course, on the derivative of inverse trig functions. We may not have them all memorized yet, so here's our formula, if you will. So in this case, the u is 2x, so the derivative of the inverse tangent function is going to be a fraction. 1 over 1 plus u squared. 1 plus, of course our u is 2x, so we're going to take 2x and square it down here in the denominator, and then it's times the derivative of our argument, the derivative of that 2x. And of course we could have done that in our head. We know that the derivative of 2x is easily 2, but let's continue from here. So dy dx is 1 over, let's see, 1 plus, when we square 2x, of course we get 4x squared, times the derivative of 2x, of course, is just 2, and so clearly we could have written that as 2 over 1 plus 4 x squared. Okay, now our job, of course, is to find the second derivative, and we already understand that to find the second derivative, we find the derivative of the first derivative. So the second derivative calculation, d squared y over dx squared, second derivative calculation is going to require us, or we'll probably want to use the quotient rule since we have a quotient here. So using the quotient rule, let's see what we get. We'll take the denominator, which is 1 plus 4x squared, my bad. Let me see if I can't make this cleaner. So we'll take the denominator, which is 1 plus 4x squared, and we'll multiply it with the derivative of the numerator. Well, the numerator being 2, that derivative is 0. That's the derivative of the numerator. And then we subtract, well, we take the numerator, which is 2, and we multiply that with the derivative of the denominator. And the derivative of 1 plus 4x squared is simply 8x. And then we divide all of that by the old denominator squared. So the old denominator is 1 plus 4x squared, and we square that. And now we look to see how this will simplify, and clearly, let's see, here's our second derivative, d squared y over dx squared represents the second derivative. This first term is 0. 0 times anything is 0, so we get a 0 in that first position, of course. And in the second position, we get negative 16x. And of course, that's all divided by 1 plus 4x squared, and that binomial is squared. And of course then we can see that we can simplify this entire fraction as negative of 16x squared, 16x over 1 plus 4x squared, the quantity squared. And notice that I put the negative in front of the fraction. We could have written the numerator as negative 16x squared, but it's more common to put that negative in front of the fraction, which is what I've done here. So we have our final result. This is the second derivative of that function above. Y equal inverse tangent of 2x.